In this example, we're going to solve an equation containing multiple exponential expressions. It's important to note that at this point, we're not going to use logarithms. Instead, we're going to use the property that a to the x is equal to a to the y if and only if x is equal to y. So as we look at this problem, we have 125 raised to the x times 5 raised to the quantity x squared equal to 1/25. So what we need to do in this problem is make sure that each side is written with the same base. So as we look at these expressions, we can see that with 125, 5, and then this 1/25, all of those can be written with base 5. So we'll look at this equation. We've got our 125 raised to the x, and that's times 5 to the x squared equal to 1/25. So we need all of those to be written with base 5. So this 125 to the x, that can be written as 5 cubed raised to the x, and then that's times 5 raised to the x squared. And then on the right-hand side, we have 1/25. And so that we can think of as 1 over 5 squared, which means that it's 5 raised to the negative 2. If we continue simplifying this left-hand side, we'll see that we get 5 to the 3x, and that's times 5 raised to the x squared, and that's all equal to 5 to the negative 2. Now, the properties we're going to use here, we have some exponent properties we'll need to use. So the first one is that if we have a raised to the m, and we raise that all to the n, then we multiply those exponents. So that's a to the m times n. And that's how we took this 5 cubed raised to the x and made it 5 raised to the 3x. The other property we have is that if we have a raised to the m times a raised to the n, then that's a to the m plus n, and that's one property we'll use next. And the other one, just one quick review, a to the negative n, that's always 1 over a to the n. All right, so continuing, this left-hand side should be 5 raised to the 3x plus x squared, and that's equal to 5 to the negative 2. Now at this point, we can use that key property we talked about. Each side has a base of 5. We're not yet going to use anything with logarithms, but if each side has base 5, then we know that what's in each of those exponents will be equivalent. So this equation here is equivalent to 3x plus x squared equal to negative 2. And at this point, this equation is quadratic, so we'll set it equal to 0, and then we'll try and factor it if possible. So we've got x squared plus 3x plus 2 equal to 0, and that one will factor. That'll factor into x plus 2 times x plus 1. So that whole thing is equal to 0. Lastly, using our zero product principle, that means that x plus 2 equals 0, or x plus 1 equals 0, and that makes x equal to negative 2, or x equal to negative 1. And as our last step, we have two solutions, negative 2 and negative 1, so we'll state our solution set. And that is the set containing the number negative 2 and the number negative 1.